this is a rod which is hinged at A, okay, here, and we have just released the rod from this horizontal position. So it is asking that which point on the rod will have the same acceleration as that of the ball. This is a ball, so we have released this rod as well as this ball at the same time. So we know that this is freely falling ball, so its acceleration will be g. Okay, so it is asking which point on this rod will have the same acceleration like this ball, that is equal to g. Now this is not a freely falling object, this is hinged here, so there will be some hinge forces which will act on this object. Okay, now this is hinged about this point A, so it is going to rotate. Okay, as it will come down, the its angular velocity will increase. Initially its angular velocity is 0, so who will increase its angular velocity? Alpha. So at this point, in this position, we are going to calculate the alpha. So how do we calculate alpha? We use this equation, torque is equals to I alpha. Okay, so now torque is going to be applied by forces. Which force? One is this mg and another is this hinge force on this rod. But the torque of hinge is going to be 0 as the distance is 0 from this line of action of force. This distance is 0, so torque of hinge force is going to be 0 because we are calculating torque about point A. Okay, so only mg is going to provide the torque. So what will be the torque of mg here? Before that, we are going to see this equation that torque is equals to I alpha. So the torque of only mg is going to be here. So the distance is torque is equals to, also we know that torque is equals to R cross F. So what is the R? R is this length and force is mg is equals to I. So the I, that is the moment of inertia about A, is ml square by 3 and this is alpha. From here we get alpha is equals to 3g by 2l. Okay, now we know the relation between alpha and tangential acceleration, that is A tangential is equals to alpha r. Okay, for all these points, because these points are going to move in circular motion, we have this relation that tangential acceleration is equals to angular acceleration into radius or the distance from the center. So this is the center of circular motion for all these points. Now we want the acceleration to be equal to g, because which point is going to have the acceleration equal to g? So we put A tangential is equals to g, that is equals to alpha x. Okay, x is the distance from this point from A. From here we get x is equals to g by alpha, and we have already calculated alpha, so we put this value down here. So from here we get L is equals to, that is x is equals to 2L by 3. Now 2L by 3 distance is from point A, but we want from point B. So what we will do is, length of rod is L, L minus 2L by 3 is equals to L by 3.